So in this video, I want to go over what you should do initially when you have an equation that you're trying to solve. So whenever you have an equation, you should always ask yourself, can I solve this equation by inspection? And all that means is, can you find the value of x that when you replace it with a number, it's going to make a true number sentence? Now, each of these equations here can be solved by inspection. So why don't you pause the video, open the notes, and see if you can solve these just by looking at it. So here's the thought process on how I thought about solving each of these equations. And the first one, it's a simple 7 plus a number equals 12. Well, the only number that if I add to 7 and get 12 is it's gonna be 5. So the first one that one's pretty straightforward. X equals 5. Okay, the other ones are a bit more complex, but we can use some reasoning and structure to figure out the answer. Okay, B says 3r plus 1/2 equals 37 over 2. Well, 37 over 2 is 18.5, right? Well, on the other side, I have a half, right? So that means that really 3r has to total 18, because 18 plus the half will get me to 18.5. Well, that means that r has to equal 6, right? Because if r is 6, well, this will be 18 from that term. 18 plus the half, that gets me to 18.5. For C, m cubed equals negative 125. So this one is about repeatedly multiplying the same amount. So you might want to say, okay, well, let me start by trying 5. 5 times 5 is 25. 25 times 5 is 125. Okay, so at least I made 125. Is there anything I can do now to make negative 125? And then you might remember, well, a negative number, right, to an odd power makes an odd result. So if I switch the 5 to negative 5, that's still going to make 125, but this time it's going to be negative 125. So for this one, m equals negative 5. Okay, for the equation D, x equals x squared. You might notice, if you try some values like, I don't know, like 2, well, the left-hand side would be 2, and the right-hand side would be 4. Well, if you increase your values of x there, like say 3, it would be 3 equals 9, 4 equals 16. So these numbers increase and obviously won't work. So you might want to try smaller values for x. Well, let's try 1. 1 equals 1 squared. Does that work? 1 squared is 1, so x equals 1 is a solution. But don't stop there, because you should also maybe think about trying negative 1. Negative 1 equals negative 1 squared. Well, negative 1 squared, it does turn to positive 1. So this one doesn't work, but it was worth checking. And a solution a lot of students will forget to check is, well, what about 0? Does 0 work? And it does in a trivial sense. 0 does equal 0 squared. So this would say 0 equals 0. So this equation actually produces two solutions. X equals 1 or x equals 0. All right, the equation in E, well, I'm dividing something, and I'm trying to get -8. Okay, if I was trying to get 8, right, that would be pretty simple. I would want the numerator to be 16, because 16 divided by 2 is 8. But since I'm trying to get -8, that means the numerator has to be -16. So I can say, well, 7 plus n has to be -16. And then, well, this one you can, if you reason through it carefully enough, I think you would see that n has to be, I think, -23. Because if you add 7 to -23, you should get -16. Yeah, that's right. For f, 2a equals a plus a. If you keep producing enough a values, try a equals 1, a equals 2, a equals 3. You'll start to see that all of these numbers actually make a true number sentence at the end. But more globally reasoning is, well, the expression on the left is the expression on the right, right? If I combine like terms here, this is 2a. So this would say that 2a is always equal to 2a, and that's true no matter what value of a I plug in. So this should be all real numbers. That means no matter what number I put in there, it's going to produce a true number sentence. In contrast, in G, I have q plus 68 equals q plus 67. So this is saying take a number, add 68. Then take the same number, add 67. Well, no matter what number I choose, one side is always going to be just one unit bigger than the other. Right, so like if you were to say let q be 0, 0 plus 68 equals 0 plus 67. The left-hand side is one bigger in this case. And it's always going to be that no matter what you pick for q. So this would be the opposite of all real numbers. This one is actually no solution. And then final equation, we have x times the quantity x plus 1 times the quantity x plus 2. And to reason through this equation, you really got to think about, well, we're multiplying three quantities here. And if I multiply it and the result is 0, well, that means that one of the things that you're multiplying has to be 0. So our solutions to this one is, well, here's that x. Maybe that is 0. If that x is 0, well, regardless of what's in the parentheses, the product of all three things would be 0. Now let's look at the x plus 1 piece. How could I make that go to 0? Well, I would need to let that be x equals -1. If x is -1, then the middle is 0. Regardless of what the other pieces are, the whole product would be 0. And our third solution here is if that last product is 0, and that would be, or that last factor is 0, that would be x equals -2. So what I like about these equations is it introduces you to thinking about solving equations by inspection, but also the different possibilities when you do solve an equation. There's situations where you have all real numbers that will work. You'll have equations where there's no solution. You'll have equations where you get 2 answers, where you get 3 answers, or equations that just have 1 answer. But always the goal is to try to solve an equation by inspection. And we're going to see over the next few videos how you can use the properties of equality to do that.